Hi, I'm Hugo Madeira, and in this video I will talk about prosthetic design and chairside milling in our daily workflow. Now, you might wonder, why should we use the digital workflow? Well, if you already have an intraoral scanner or you are thinking about having one, you have to make the most of it. Why? Digital dental technology is entering into a mainstream stage of adoption and is used by approximately 34% of clinicians. Digital scanning devices are rapidly developing in many fields of dentistry. Thanks to the milling machine, we can close the gap on our digital workflow and provide the final restoration to the patient the same day. So, let's see how we can achieve this. Is the digital workflow more efficient than the established conventional pathway for implant-supported crowns? Digital scanning has brought innovative dental treatments, such as computer-guided implantation in combination with CBCT scan or digital impression system, which allows for CAD/CAM-based restorations. Acquiring accurate impressions and transferring intraoral images are important steps for fabricating precise dental restorations. Direct digitalization showed higher accuracy compared to conventional impression taking and indirect digitalization. Due to the elastic properties of the impression materials, indirect digitalization of the impression was not recommended. Digital impressions can be sent to a lab or remain in the scanning system for an in-house fabrication of the final rehabilitation. We have ability to use technology to design and manufacture the corresponding restorative components. Custom abutments are designed digitally and milled out of the material of our choice. These digital design and manufacturing methods have gained popularity. Digitally designed and milled provisional restorations can be fabricated before the surgical procedure for immediate loading. When comparing this digital workflow to a conventional approach, digital technology has been shown to be more efficient. The dentist also benefits from this, as means the clinical adjustment and sitting time is significantly faster than for restorations fabricated with conventional methods. So, why not to give a try? So, what are the steps from the beginning until the final restoration? First, we start with the impression, with an intraoral scanning of the patient's situation or with a conventional impression scanned with the lab scanner. Once the design is completed, we can directly transfer it to a milling solution of our choice, either in lab or at a centralized milling center. We open the STL files and the magic begins. We start to design the restoration, the personalized abutment with the indications, and what we expect for our final restoration. There are some aspects to consider, like the shape of the proposed restoration, including anatomy, cusps, marginal reeds, and emergency profile, by analyzing and mimicking the anatomical features of the adjacent teeth. Occlusion is automatically computed from the antagonist teeth. We can choose from a huge range of materials and blocks. When the final design is ready, we send it to the milling machine, which mills the restoration. If we choose zirconia or cobalt chromium, after milling the restoration, it goes to the furnace to fully automated sintering. At the end, the required finishes are made, such as polishing, colored pigments, or anatomy. As you can see, it is simple and the system can handle the majority of our work.
Hi, my name is Jessica Duque. I'm a digital dental technician, and now I will show you how the milling machine works.
Jessica, I can see that you have here a block. What you can have from that block?
Crowns, bridge, onlays, overlays.
Yeah. You can have almost every kind of works from this milling machine.
Yes.
And after this, it's necessary any kind of process till the crown?
Only crystallization.
And how many time took the crystallization, for example?
10 minutes.
Okay, this is a reduction process. We have a block, and then with the drills inside of this milling machine, we can transform the block into our final product, our crown, our veneer. Yeah?
Yeah.
How does the milling machine receive the information to produce this kind of work?
This milling machine is connected to the software and is very fast.
And what kind of materials can you mill in this machine?
Lithium disilicate, PMMA, zirconium, titanium.
Almost every kind of materials.
Yes.
And you can mill surgical guides also?
Yes, it's possible.
Jessica, what can you say about the quality of the materials that come from this milling machine?
The products are made with accuracy, high quality and precise.
Dentists, lab technicians, as well as patients, they all benefit from this digital workflow that delivers time savings and allows for more time in communication and patient care. To make the restorations, you have two options, either sending to a milling center or purchasing a milling and grinding equipment for an in-house process. If you use zirconia or cobalt chromium, you will need a furnace to sinter in the end. It improves the daily practice routine in terms of efficiency and productivity. CAD/CAM offers a unique portfolio of materials to provide a wide range of treatment options. All types of dental materials can be processed, providing high versatility and giving you the choice of material you need to serve your patients. So, which materials should you have in your clinic to mill? Glass ceramics as nice and Max for inlays, onlays, veneers or crowns. Hybrid ceramics as Lava or Vita for inlays, onlays, veneers and crowns too. Ceramics for the same application as the materials before bridges, bars and zirconia abutments. Then we have metal crowns, bridges and bars, screw-retained or not, and abutments. Other material used more usually for temporary restorations, abutments and splints is the polymer as wax, PMMA and PEEK. PEEK is a lightweight alternative to traditional metal framework, is steam steerable and highly biocompatible, providing high flexibility. This material is strong and durable, indicated for up to final full arch restoration. So, we saw that advances in digital technologies provide clinicians with the tools for diagnosis, treatment planning, placement and restoration of implants in a truly transformative way. To make the most of our digital workflow and increase the effectiveness of our final results, the milling machine is a good solution to reduce our time, material waste and costs. Digitally designed and milled provisional restorations can be fabricated before the surgical procedure for immediate loading. The digital workflow is a great communication tool for our patient. It helps us to show them in advance the final outcomes and to present them the most effective and precise treatment plan they need.